Get the free nodes of electrical circuit. Install the app from the pin command. Nodal analysis. Question. Using node voltage method, find the current in the 3 ohm resistor in figure. Here in this circuit, we have to find this current I, that is the current through this 3 ohm resistor, by using nodal analysis. Solution. First of all, let's say this is a node with voltage V1. Let's say this is a node with voltage V1 and this is a reference node. Here this is a reference. This is current I and let's say this current is I1 and let's say this current is I2. All the currents towards this reference node. Now here at this node we will apply KCL. To apply KCL, that is Kirchhoff's current law, at node V1. Now according to KCL, summation of all the currents entering a node is equal to summation of all the currents leaving the node. So here at this node the entering current is this current I and this current I1. These are the entering current at this node V1. So it will be I plus I1. It will be I plus I1 is equal to. Now leaving current or outgoing current. Here we can see this current is leaving from this V1. So it is I2. So is equal to I2. Now we will write this in voltage form. So I will be, now here we can see this is negative and this is positive. Here this is negative and this is positive. So they will get added. That is 4 plus 2. So first of all we will write 4 plus 2 and then minus this voltage, that is V1. So minus V1 divided by resistance 2 plus 3. 2 plus 3. Now plus is plus. Now I1. For I1, expression for I1 will be this 4 minus V1 divided by 2. 4 minus V1 divided by 2 is equal to I2. Now this I2 will be V1 minus 0. This reference voltage is 0 volt. So V1 minus 0 divided by 2. V1 minus 0 divided by 2. So if we simplify this, so it will be 4 plus 2, that is 6. So 6 divided by, this will be 5. 2 plus 3 is 5. Then minus V1 divided by again 5. Then plus, this will be 4 by 2. 4 divided by 2 minus V1 divided by 2. Then is equal to V1 by 2. 1 divided by 2. Or we can directly take this on this side. So it will be minus V1 divided by 2 is equal to 0. Now here this 6 by 5 plus 4 by 2. This is constant. So we will solve this. 6 divided by 5. Then plus 4 by 2. So it is 3.2. So it will be 3.2. And now this V1. So let's take V1 as common. So we will take plus V1 here and in bracket this will be minus 1 by 5. So minus 1 by 5. Then minus 1 by 2. Minus 1 by 2. Then minus 1 by 2 again. So minus 1 by 2. Minus 1 by 5. Minus 1 by 2. And again minus 1 by 2. So it is minus 1.2. Minus 1.2 is equal to 0. So if we take this on right side, so it will be, or if we take this on right side, so it will be 3.2 is equal to V1 in bracket 1.2. Now we can find the value of V1. V1 is equal to 3.2 divided by 1.2. So it is 3.2 divided by 1.2. So it is 2.6. 2.6 volt is the value of V1. But here we have to find the value of current I. And here we can see current I is equal to, again we can write, but current I is equal to, so it is 4 plus 2 minus V1. 4 plus 2 minus V1 divided by resistance. So resistance is 2 plus 3. 2 plus 3. The value of V1 is 2.6. So it will be 4 plus 2 is 6 minus V1 is 2.6 divided by 2 plus 3 is 5. So if we solve this, then it will be 6 minus 2.6 divided by 5. So it is 0.68. 0.68, and since it is current, so its unit will be ampere. So therefore current I is equal to 0.68 ampere. So this is the value of current I, that is the current through this 3 ohm resistor. This is what we have to find. Check the link in the comment section and install the app to get the free notes of electrical circuit. Thanks for watching. To get the free notes of electrical circuit, check the link in the comment section and install the app for free. Nodal analysis. Question. Write the node voltage equations and determine the currents in each branch for the network given in figure. Here in this circuit, we have to determine node voltage equations and determine the branch current by using nodal analysis. Solution. First of all, let's say this is a node 1 with voltage V1 and this is node 2 with voltage V2. Let's say this is current I1, this is current I2, this is current I3, and this is current I4, and here let's say this is current I5. All the currents toward reference node. This is the reference node with 0 voltage. Now let's apply KCL at node V1. Apply KCL. KCL stands for Kirchhoff's current law. Apply KCL at node V1. Now according to KCL, summation of all the current entering a node is equal to summation of all the current leaving the node. That is I in is equal to I out. Now here we can see at this node the entering current is I1 and leaving currents are I2 and I3. These are the leaving current and this is the entering current. So here we can write I1 is equal to I2 plus I3. Here we can see I1 is equal to 5 ampere. Here we can write I1 is equal to 5 and I2 in voltage form will be V1 minus 0 divided by 10. V1 minus 0 divided by 10, then plus I3. Now this I3 is V1 minus V2 divided by 3. V1 minus V2 divided by 3. Now let's simplify this. So it will be 5 is equal to V1 by 10, then plus V1 by 3 minus V2 by 3. V2 by 3. Now if we solve this, so it will be V1 in bracket 1 by 10 plus 1 by 3. So 1 by 10 plus 1 by 3 is 1 by 10 plus 1 by 3. So it is 13 by 30. 13 divided by 30. Now it is equal to minus V2, and here this will be 1 by 3 is equal to this 5 as it is. Let's say this is equation number 1. Now next apply KCL at node 2. So apply KCL at node 2. Again, according to KCL, summation of all the entering current is equal to summation of all the current leaving the node. Now here at this node, the entering current is I3 and I5. These are the entering current. So here we can write I3 plus I5 is equal to I3 plus I5 is equal to I4. Now I3 in voltage form will be V1 minus V2 divided by 3. V1 minus V2 divided by 3. Then plus I5. So I5 is 10 minus V2 divided by 1. 10 minus V2 divided by 1 is equal to I4. Now this I4 is V2 minus 0 divided by 5. V2 minus 0 divided by 5. Now again simplify this, so it will be V1 by 3. V1 divided by 3 minus V2 divided by 3. Then plus this will be 10 minus V2. V1 by 3 minus V2 by 3. Then plus 10 minus V2. Then if we take this on left side, so it will be minus V2 by 5 is equal to 0. So here this will be V1 in bracket 1 by 3. Then here if we take this plus V2 common, then in bracket this will be minus 1 by 3. So let's solve this. Minus 1 by 3. Then minus 1. Then minus 1 by 5. Minus 1 by 5. So it is minus 23 by 15. Minus 23 divided by 15 is equal to, now this will be, if we take this 10 on right side, so it will be is equal to minus 10. Let's say this is equation number 2. Now we have equation number 1 and equation number 2. So let's solve this. So mode, then 5. There are two unknowns, so equation number 1. Now this will be 13 by 30. 13 divided by 30, and it will be minus 1 by 3. So minus 1 divided by 3 and is equal to 5. And here this will be 1 by 3. 1 divided by 3. This will be minus 23 divided by 15 is equal to minus 10. So therefore V1 is equal to 19.87 volt, and V2 is equal to 10.84 volt. Now next is we have to determine the current in each branch for the network. So we have to determine I1, I2, I3, I4 and I5. So let's write I1 is equal to, I2 is equal to, I3 is equal to, I4 is equal to, and I5 is equal to. Here we can see I1 is equal to 5 ampere directly. So I1 is equal to 5 ampere, then I2. Now I2 is V1 minus 0 divided by 10. V1 minus 0 divided by 10. The value of V1 is 19.87. 19.87 divided by 10. So it will be 19.87 divided by 10. So it is 1.987. 1.987. Then it is current, so its unit will be ampere. Then I3. So I3 is V1 minus V2 divided by 3. V1 minus V2 divided by 3. So the value of V1 is 19.87 minus the value of V2 is 10.84. 10.84 divided by 3 is equal to, so this will be minus 10.84 divided by 3. So it is 3.01 ampere. 3.01 ampere. Then next is I4. So I4 is V2 minus 0 divided by 5. V2 minus 0 divided by 5. The value of V2 is 10.84. So 10.84 divided by 5. So it will be 10.84 divided by 5. So it is 2.168. 2.168 ampere. Then last is I5. So here we can see I5 is equal to 10 minus V2 divided by 1. 10 minus V2 divided by 1. So it will be 10 minus 10.84 divided by 1. So 10 minus 10.84. So it is minus 0.84. Minus 0.84 ampere is the value of I5. So this is how we can find branch current and node voltage equation by using nodal analysis. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuit, check the link in the comment section and install the app for free. Nodal analysis. Question: determine the voltages at nodes B and C in the network shown in figure using node analysis. Here in this circuit, we have to find this node voltage and this node voltage by using nodal analysis or node analysis. Solution: first of all, let's say this is a node with voltage VB and this is a node C with voltage VC. Now here the direction of current is already given. Let's say this is a reference node with 0 voltage. Now here let's apply KCL at this node. Apply KCL, that is Kirchhoff's current law, at node B. Now according to KCL, that is Kirchhoff's current law, summation of all the current entering a node is equal to summation of all the currents leaving the node. Now here at this node, the entering current is this current. Let's say this is current I1 and this current is 30 ampere. Let's say this current is I2. This current is 20 ampere and let's say this current is I3. So here at this node, the entering current is I1 only and leaving currents are 30 ampere and 2 I2. So it will be I2 is equal to leaving currents are 30 ampere plus I2. 30 ampere plus I2. The entering current is I1. Here this is I1, not I2. This is I1. Now we will write this I1 in voltage form. So it will be 120 minus VB. 120 minus VB divided by 0.2 ohm. 0.2 is equal to 30 plus I2. Now this I2 is This I2 is VB minus VC divided by 0.3. VB minus VC divided by 0.3. Now let's simplify this. So it will be 120 divided by 0.2 minus VB divided by 0.2. Then if we take this, we will keep this 30 on right side and we will take this VB by 0.3 on left side. So it will be minus VB by 0.3 and this will be plus VC by 0.3 is equal to 30. Now here we can solve this. So it will be VB in bracket, this will be minus 1 by 0.2 minus 1 by 0.2, then minus 1 by 0.3. So it will be minus 8.3 minus 8.3. Then this will be plus VC in bracket 1 by 0.3 is equal to 30. And if we take this on right side, so it will be minus 120 divided by 0.2. So again this will be VB in bracket minus 0.8, it is 8.3, then plus VC 1 upon 0.3 is equal to, this will be 30 minus 120. So 30 minus 120 divided by 0.2. 30 minus 120 divided by 0.2. So it is minus 570. Minus 570. Let's say this is equation number 1. Now next we will apply KCL at node C. Next is apply KCL at node C. So according to KCL again, summation of all the currents entering a node is equal to summation of all the currents leaving the node. So here the entering currents are I2 plus I3. These are the entering currents. I2 plus I3 is equal to, leaving current is only 20 ampere. 20 ampere, here we write. Now I2 in voltage form will be VB minus VC divided by 0.3. VB minus VC divided by 0.3, then plus I3. So I3 will be 116 minus VC. 116 minus VC divided by the value of resistance 0.1 ohm. 0.1 is equal to 20. Again simplify this, so it will be VB by 0.3 V divided by 0.3 minus VC divided by 0.3 plus 116 divided by 0.1 minus VC divided by 0.1 is equal to 20. So here we take this VB common here, it will be VB 1 upon 0.3. Then next we take this VC common, so it will be, we will take plus VC common. So in bracket this will be minus 1 by 0.3 minus 1 upon 0.3, then minus 1 upon 0.1. So it is 13 minus 13.3 minus 13.3 is the value of VC is equal to, now we will directly solve this, 20 minus 116.01. 20 minus 116 divided by 0.1. So it is minus 1140. Minus 1140. Now this is equation number 2. So solving equation 1 and 2, we get VB and VC. So VB is equal to and VC is equal to. So let's solve in calculator. So mod 5 and 1. So it will be minus 8.3, 1 divided by 0.3 equal to minus 570. Then next from equation 2 it will be 1 divided by 0.3, and here this will be minus 13.3, and this is minus 1140. So therefore VB is equal to 114.63, 114.63 volt, and VC is equal to 114.44 volt. This is the value of VB and VC. What we have to find in this question, we have to determine the voltages at nodes B and C in the network shown in figure using nodal analysis or node analysis. So here this is the value of VB and VC by using nodal analysis. To get the free nodes of electrical circuit, check the link in the comment section and install the app for free. Thanks for watching. To get the free nodes of electrical circuit, check the link in the comment section and install the app for free. Nodal analysis. Question: by using nodal analysis, calculate the current in 132 ohm resistor and PD, that is potential difference across 20 ohm resistor as shown in figure. So we have to find the voltage across this 20 ohm resistor, and we have to find current through this 132 ohm resistor, and also we have to find this node voltage. So let's see solution. Let's say this is a node 1, and let's say this is current I1, this is current I2, and this is current I3 according to this polarity of voltages. And let's say this is the reference node with 0 voltage. All the currents towards this reference node from this positive polarity to this reference node. Now let's apply. We will take this on this side more like this. On this side we can do calculations. Apply KCL, that is Kirchhoff's current law, at node 1. Now let's say this node voltage is V1. KCL stands for Kirchhoff's current law. According to KCL, summation of all the current entering a node is equal to summation of all the currents leaving the node. So summation of I in is equal to summation of I out. Now here the entering currents are I1 and I3. I1 plus I3 is equal to leaving current is I2. So let's write I1 in voltage form. So it will be 200 minus V1, 200 minus V1 divided by 20, then plus I3. Now I3 will be 100 minus V1, 100 minus V1 divided by 60 is equal to I2. Now I2 will be V1 minus 0, divided by 132. Now let's solve this and get the value of V1. So this will be 200 divided by 20 minus V1 divided by 20, then plus 100 divided by 60 minus V1 divided by 60, and if we take this on left side, so it will be minus V1 divided by 132. 132 is equal to 0. So let's solve this. We will take V1 common from here. So in bracket this will be minus 1 upon minus 1 upon 20, then minus 1 upon 60, then minus 1 upon 132, minus 1 upon 132. So it is minus 49 by 660. And if we solve this, so it will be 200 divided by 20. So it is 10. And this will be plus 100 upon 60. So it is 11.6. We take this on right side, so it will be minus 11.6. Now we can easily solve this and get the value of V1. This minus and this minus will get cancelled. So V1 is equal to 11.6 multiplied by 660 divided by 49. Therefore, V1 is equal to 11.6 multiplied by 660 divided by 49. So it is 156.24. 156.24 volt is the value of V1. Now we got the value of this voltage. So you can easily find the value of this I2. I2 is equal to V1 minus 0 divided by 132. V1 minus 0 divided by 132. So the value of V1 is 156.24 divided by 132. So it will be 156.24 divided by 132. So it is 1.18. 1.18 ampere is the value of I132 ohm. That is the current through 132 ohm is 1.18 ampere. Then next we have to find the potential drop across 20 ohm. So to calculate the voltage drop across this 20 ohm, that is V20 ohm. This is V20 ohm. It is equal to resistance multiplied by current I1. That is 20 multiplied by I1. So V20 ohm is equal to 20 multiplied by I1. So it will be 20 multiplied by the value of I1 will be 200 minus V1 divided by 20. 200 minus V1 divided by 20. So this will be 20 multiplied by 200 minus the value of V1 is 156.24. 156.24 divided by 20. So this will be 20 multiplied by 200 minus 156.24 divided by 20. So it is 43.76, and since it is a voltage, so its unit will be volts. So this is the answer for V20, that is voltage drop across 20 ohm resistor. So this is how we can solve current and potential difference across 20 ohm by using nodal analysis. Check the link in the comment section to get the free notes of electrical circuit, and also thanks for watching. To get the free notes of electrical circuit, visit the link in the comment section and install the app for free. Nodal analysis. Question: using nodal analysis, calculate the current distribution for the circuit shown in figure. Here in this circuit, we have to find the current through this 0.1 ohm resistor, this 1 ohm resistor, and this 0.05 ohm resistor by using nodal analysis. Solution: let's say this is node 1 with voltage V1 and this is a reference node. Let's say this is current, this is positive polarity, so the current will be like this. Let's say this is current I1 and this is current I2, and from this positive polarity to this ground, so let's say this is current I2. Now we will apply KCL, that is Kirchhoff's current law, to node 1. Now according to KCL, summation of all the current entering a node is equal to summation of all the currents leaving the node. Now here the entering currents are I1 plus I2. It will be I1 plus I2, and leaving current is, this is I3, this is I1, this is I2, and this is I3. Entering current will be I1 plus I3. I1 plus I3 is the entering current, and this I2 is the leaving current. Now we will write this I1 in voltage form. So it will be 3 minus V1 divided by 0.1, then plus I3, it will be 2 minus V1 divided by 0.05, 2 minus V1 divided by 0.05 is equal to I2. It will be V1 minus 0 divided by 1. So we can directly write V1 only. Now we will simplify this further. So it will be 3 divided by 0.1 minus V1 divided by 0.1 plus 2 divided by 0.05 minus V1 divided by 0.05 minus V1 is equal to 0. So let's take V1 common from here. So V1 in bracket, this will be minus 1 upon 0.1, then minus 1 upon 0.05, then minus 1, minus 1. So let's solve this. So it is minus 31. Then this will be 3 divided by 0.1, then plus 2 divided by 0.05 is equal to 70. This will be plus 70 is equal to 0. So this will be V1 in bracket 31 is equal to 70. This minus will get cancelled if we take this on right side. So therefore V1 is equal to 70 divided by 31, and 70 divided by 31 is 2.25. 2.258, and since it is a voltage, so its unit will be volts. So V1 is equal to 2.258 volt. But we have to find the current through this branch, and this branch. That is I1, I2, and I3. So I1 is equal to 3 minus V1 divided by 0.1. 3 minus V1 divided by 0.1 is equal to, the value of V1 is again 3 minus 2.258 divided by 0.1. So this will be 3 minus 2.258 divided by 0.1. So it is 7.42. 7.42 ampere is the value of current I1. Then current I2. current I2 will be V1 minus 0 divided by 1. V1 minus 0 divided by 1. The value of V1 is 2.258. 2.258, and since it is current, so its unit will be ampere. Then next is I3. So I3 will be 2 minus V1. 2 minus V1 divided by the value of resistance. It is 0.05 ohm. 0.05. So it will be 2 minus the value of V1 is 2.258. 2.258 divided by 0.05. 2 minus 2.258 divided by 0.05. So it is minus 5.16 ampere. So this is how we can find the branch currents and node voltage by using nodal analysis. Check the link in the comment section and install the app for free. Also, thanks for watching. To get the free notes of electrical circuit, check the link in the comment section and install the app for free. Nodal analysis. Question: for the circuit shown in figure, calculate current through 30 ohm resistance using nodal analysis. In this circuit, we have to find the current through this 30 ohm by using nodal analysis. Solution: first of all, let's copy this circuit from here. Let's say this is a node 1 with voltage V1, and this is a reference node or ground node. Let's say this is current I1 from this positive polarity of this voltage source to ground, and let's say this is current I2, and from this positive terminal to this ground, let's say this is current I3. All the currents towards this reference node. Now let's apply KCL at node V1. Apply, or we will take this circuit on this side. Apply KCL, that is Kirchhoff's current law, at node V1. Now here we can see, according to KCL, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node, the entering currents are I1 is the entering current, and also this I3 is the entering current, and this I2 is the leaving current. So it will be I1 plus I3 entering current, and leaving current is I2. Now let's write this I1 in voltage form. So it will be 20 minus V1, 20 minus V1 divided by this resistance value, that is 20 ohm, then plus I3. Now I3 in voltage form will be 10 minus V1, 10 minus V1 divided by resistance value is 10 ohm, is equal to I2. Now this I2 will be V1 minus 0, V1 minus 0 divided by resistance value is 30 ohm. So this will be 20 divided by 20. Now let's simplify this. 20 divided by 20 minus V1 divided by 20 plus 10 divided by 10 minus V1 divided by 10 is equal to, or directly we can take minus. If we take this on left side, so it will be minus V1 divided by 30 is equal to 0. Now here, if we take this V1 common, then in bracket this will be minus 1 by 20. So let's solve this. Minus 1 divided by 20, then minus 1 by 10, minus 1 divided by 10, then minus 1 by 30. minus 1 by 30, minus 1 by 20, minus 1 by 10, minus 1 by 30. So it is minus 11 by 60, minus 11 divided by 60. Then if we solve this, it will be 1 and this will be 1. 1 plus 1, 2. 2 plus 2 is equal to 0. Or we can directly take this 2 on right side. So it will be minus 2 is equal to minus 2. Now we can, this minus and this minus will get cancelled. We can calculate the value of V1. V1 is equal to 2 multiplied by 60 divided by 11. It will be 2 multiplied by 60 divided by 11. So it is 10.90. 10.90 volt is the value of V1. But we have to find the current through 30 ohm. We have to find this current, that is I2. So I2 is equal to I 30 ohm, that is current through 30 ohm, and it will be V1 minus 0 divided by 30. V1 minus 0 divided by 30. The value of V1 we have just calculated, it is 10.90 divided by 30. So it will be 10.90 divided by 30. So it is 0.363, 0.363, and since it is current, so its unit will be ampere. So this is the value of I 30 ohm, 0.363 ampere. So this is how we can find the value of current by using nodal analysis. Check the link in the comment section and install the app for free. Also, thanks for watching. Get the free notes of electrical circuits. Check the link in the comment section and install the app for free. Nodal analysis. Question: find current through 8 ohm resistance. Here in this circuit, we have to find the current through this 8 ohm resistor by using nodal analysis. Solution: let's say this is a node 1 with voltage V1, and let's say this is a reference node or ground node with 0 voltage. Let's assume, according to the polarity of this voltage source, let's say this is current I1, all the currents towards this reference node, and let's say this is current I2. According to the polarity of this voltage source, let's say this is current I3. Now here, apply KCL at node V1. Apply KCL at node V1. KCL stands for Kirchhoff's current law. According to KCL, summation of all the entering current, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node, the entering currents are, this I1 is the entering current and this I3 is the entering current. Here we can write I1 plus I3 is equal to leaving current is only I2. Here we can write is equal to I2. Now let's write I1 in voltage form. So it will be 20 minus V1 divided by 6. 20 minus V1 divided by 6. Then plus, now I3 in voltage form will be 12 minus V1 divided by 10. 12 minus V1 divided by 10 is equal to, now this I2 will be V1 minus 0 divided by 8. V1 minus 0 divided by 8. Now simplify this. So it will be 20 divided by 6. Then minus V1 divided by 6. Then plus 12 divided by 10. then minus V1 divided by 10. If we take this on left side, so it will be minus V1 divided by 8 is equal to 0. So let's take V1 common from here. It will be minus 1 by 6 minus 1 by 6, then minus 1 by 10 minus 1 upon 10, then minus 1 upon 8 minus 1 upon 8. So it is 0 point, or we can write this minus 47 by 120 minus 47 divided by 120. Now let's solve this constant. So it will be 20 divided by 6, 20 by 6, then plus 12 divided by 10. The constant, so it is 68 by 15 plus 68 divided by 15 is equal to 0. We take this on right side, so it will be like this. Negative will be positive, and we can write like this. 47 divided by 120 is equal to 68 divided by 15, and again V1 is equal to 68 multiplied by 120, 68 multiplied by 120 divided by 15, and this will be multiplied by 47. 68 into 120 divided by 15 into 47. So let's simplify this. 68 multiplied by 120 divided by 15 multiplied by 47. So it is 11.57. 11.57. Since it is a voltage, so its unit will be volts. Where we can write V1 is equal to 11.57 volt. But here we have to find the value of this current, the current through 8 ohm resistance. So the current through this 8 ohm resistance will be I2. Here we can write I2 is equal to I8 ohm is equal to, now this I2 is V1 minus 0 divided by 8. V1 minus 0 divided by 8. The value of V1 is 11.57 divided by 8. 11.57 divided by 8. So it is 1.446. 1.446. Since it is current, so its unit will be ampere. Therefore, I8 ohm is equal to 1.446 ampere. So this is how we can find the value of current by using nodal analysis. Check the link in the comment section and install the app for free to get the notes of electrical circuits. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question: find the current through 2 ohm resistance. Here in this circuit, we have to find the current through this 2 ohm resistance by using nodal analysis. Solution: first of all, let's assume this is a node A and this is node B. This node voltage is VA and this node voltage is VB. And let's assume this is a reference node or ground node with 0 voltage. Let's say this is current I1. This is current I2. This is current I3. This is current I4. And this is current I5. All the currents towards this reference node. Now here at this node A, we will apply KCL.
So apply KCL at node A. Now here we can see, according to KCL, that is Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see, at this node the entering current is I1. Here we can clearly see I1 is equal to 6 ampere. So first we will write I1 as it is, then is equal to leaving currents. The leaving currents are I2 and I3. These are the leaving currents from this node. So here we can write I2 plus I3. Now here this I1 is equal to 6 ampere. So here we can write 6 is equal to I2. Now this I2 will be VA minus 0 divided by 4. VA minus 0 divided by 4, then plus I3. Now this I3 will be VA minus VB divided by 2. VA minus VB divided by resistance value, that is 2. Now let's simplify this. So it will be 6 is equal to VA by 4, then plus VA by 2 minus VB by 2. Now here if we take this VA common, so it will be VA in bracket 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2. So it is 0.75. 0.75 minus VB, or we will take plus VB common, and this will be minus 0.5 is equal to 6. Let's say this is equation number 1. Now next we will apply KCL at node VB. Apply KCL at node B. Now here we can see, at this node the entering currents are I5 plus I3. So I5 plus I3, it is equal to I5 plus I3 is equal to I4. Now here the value of I5 is, here we can see I5 is equal to 24 minus VB divided by 6. 24 minus VB divided by 6 plus I3. Now this I3 value will be VA minus VB divided by 2. VA minus VB divided by 2 is equal to I4. Now this I4 value will be VB minus 0 divided by 5. VB minus 0 divided by 5. Now let's simplify this. So it will be 24 by 6. So this will be 4 minus VB by 6 plus VA by 2 minus VB by 2. If we take this on left side, so it will be minus VB by 5 is equal to 0. Now here we can see this VA, if we take this VA common, it will be VA in bracket 0.5, then plus, now if we take this VB common, so this will be minus 1 by 6 minus 1 by 6, then minus 1 by 2, then minus 1 by 5. So it is minus 13 by 15 minus 13 divided by 15. Now if we take this 4 on right side, so it will be minus 4. Let's say this is equation number 2. Now we got two equations, equation number 1 and equation number 2. So solving equation 1 and equation 2. So if we solve these two equations, then we get mod 5, then 1, 0.75, then minus 0.5, then 6, and here from equation number 2 this will be 0.5 minus 13 by 15 minus 4. So therefore VA is equal to 18 volt and VB is equal to 15 volt. Now we got this nodal voltages, but we have to find the value of the current through 2 ohm resistance. So the current through 2 ohm resistance is I3. So here we can write I2 is equal to I2 ohm is equal to I3, and this I3 is equal to VA minus VB divided by 2. VA minus VB divided by 2. The value of VA is 18, the value of VB is 15 divided by 2. So this will be 18 minus 15 divided by 2. So it is 1.5 ampere. 1.5 ampere is the value of I2 ohm. So I2 ohm is equal to 1.5 ampere. So this is how we can find the value of current by using nodal analysis. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question: find branch currents by using nodal analysis. Here in this circuit, we have to find all the branch currents by using nodal analysis. Solution: first of all, let's say this is current I1 and let's say this is a reference node. So all the currents towards this reference node. Let's say this is current I2, this is current I3, this is current I4 and this is current I5. Now let's say this is node 1 with voltage V1, this is node 2 with voltage V2. Now first of all, let's apply KCL at node V1. So let's apply KCL at node V1. According to KCL, that is Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node, the entering currents is only I1 is the entering current. So here we will write I1 is equal to leaving currents are I2 and I3. So I2 plus I3. Now we will write this. Here we can see clearly I1 is equal to 3 ampere. So this will be 3 ampere is equal to I2. Now I2 will be V1 minus 0. This node voltage is 0 because it is connected to reference node. So V1 minus 0 divided by 2. V1 minus 0 divided by 2, then plus I3. Now this I3 will be V1 minus V2 divided by 5. V1 minus V2 divided by 5. Now let's simplify this. So it will be 3 is equal to V1 by 2, then plus V1 by 5, then minus V2 by 5. So let's write V1 terms first. So it will be V1 in bracket 1 by 2 plus 1 by 5. 1 by 2 plus 1 by 5. So it is 0.7. Then this will be minus V2, or let's take plus V2, and in bracket this will be minus 1 by 5. So minus 1 by 5 means it is 0.2 minus 0.2 is equal to this 3 as it is. Let's say this is equation number 1. Now next we will apply KCL at node V2. So let's apply KCL at node V2. Now here we can see summation of all the entering current at the node is equal to summation of all the currents leaving the node. Now here entering current is I3. So I3 is equal to leaving currents are I4 plus I5. I4 plus I5. Now this I3 is, here we can see I3 is V1 minus V2 divided by 5. V1 minus V2 divided by 5 is equal to I4. Now this I4 is V2 minus 0 divided by 1. V2 minus 0 divided by 1. Then plus I5. Now here we can clearly see I5 is equal to 2 ampere. So this is 2 ampere. Now let's simplify this. So it will be V1 by 5. So it is V1 divided by 5. Then minus V2 divided by 5. Now if we take this on left side, so it will be minus V2 only is equal to 2. So here we can see it will be V1 in bracket 0.2. 1 by 5 means 0.2. And here if we take this plus V2 common, so it will be minus 1 by 5 minus 1. So minus 1 by 5 minus 1. So it is minus 1.2 is equal to 2. Let's say this is equation number 2. Now we got two equations, equation number 1 and equation number 2. So here we can write solving equation 1 and 2, we get, if we solve equation 1 and 2, we get V1 is equal to and V2 is equal to. So let's substitute these values in calculator. Mode 5, then 1. So it is 0.7, then minus 0.2, then is equal to 3. And here this will be 0.2 minus 1.2, then 2. So therefore V1 is equal to 4 and V2 is equal to minus 1. Since it is voltage, so its unit will be volts. Now what we have to find in this question, we have to find branch currents. That is, we have to find I1, I2, I3 and I4 and I5. So let's write branch currents. The branch currents are I1, I2, I3, I4 and I5. Now here we can see I1 is equal to 3 ampere. So I1 is equal to 3 ampere. Then I2 is equal to V1 minus 0 divided by 2. V1 minus 0 divided by 2. The value of V1 is 4 volt. So 4 minus 0 divided by 2. So it will be 2 ampere. Then I3. I3 is V1 minus V2 divided by 5. V1 minus V2 divided by 5. The value of V1 is 4 and the value of V2 is minus 1. So 4 minus 1 divided by 5. So it will be 5 divided by 5. So 5 by 5 is 1 ampere. Then next is I4. So I4 is V2 minus 0 divided by 1. V2 minus 0 divided by 1. The value of V2 is minus 1. So it will be minus 1 divided by 1. It is minus 1 ampere. Then next is I5. Here we can clearly see I5 is equal to 2 ampere. So it will be 2 ampere. So these are the branch currents. So this is how we can find branch currents by using nodal analysis. Check the link in the comment section and install the app for free to get the notes of electrical circuits. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question. Find the current in 40 ohm and 10 ohm resistance. Here in this circuit, we have to find the current through this 40 ohm resistance and this 10 ohm resistance by using nodal analysis. Solution. First of all, let's consider this is node 1 with voltage V1 and this is node 2 with voltage V2. Now let's assume, first of all, let's assume this is a reference node or ground node with 0 voltage. Now let's assume this is current I1, all the currents towards this reference node from this positive terminal to this reference node. Now let's say this is current I2, this is current I3, this is current I4 and this is current I5, or let's say this is current I5 from positive to this ground. Let's say this is current I5. So first step is to apply KCL at node V1. Apply KCL at node V1. KCL stands for Kirchhoff's current law. Now according to KCL, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see at this node V1, the entering current is this I1. It is the entering current. So let's write entering current first, I1, and it is equal to leaving current or outgoing current. The leaving currents are I2 and I3. So here we can write I2 plus I3. I2 plus I3. Now this I1 in voltage form will be 50 minus V1 divided by 15. 50 minus V1 divided by 15, it is equal to I2. Now I2 will be V1 minus 0 divided by 10. V1 minus 0 divided by 10. Then this plus as it is, then I3. This I3 will be V1 minus 20. We take higher voltage minus lower voltage. So V1 is the higher voltage we are considering and this 20 volt is the lower voltage. So it will be V1 minus 20 first. V1 minus 20. Then again this is also the lower voltage we are considering because current is flowing from V1 to V2. So it will be V1 minus 20 minus V2. So minus V2 divided by resistance value. The value of resistance is 20 ohm. So 20 ohm is this. If this resistance was absent, that time this will be a super node. But here the resistance is present. So that's why we will solve it like this. Now next, let's simplify this. So it will be 50 divided by 15. minus V1 divided by 15. Then if we take this on left side, so it will be minus V1 by 10. Then it will be again minus V1 by 20. Then minus 20 divided by 20. This will be plus if we take this on left side. And this will be again plus V2 divided by 20 is equal to 0. Now let's take V1 common from here. So if we take V1 common, then it will be minus 1 by 15 minus 1 upon 15, then minus 1 upon 10 minus 1 upon 10, then minus 1 upon 20 minus 1 by 20. So it will be minus 13 by 60, minus 13 divided by 60, minus 13 divided by 60. Now again we take this V2 common, so it will be 1 upon 20. So it will be 1 divided by 20. So 1 divided by 20 is 0.05. 0.05. Now we solve this constant, so it will be 50 divided by 15. 50 divided by 15, then plus this will be 1, so plus 1. It is 13 divided by 3, so plus 13 divided by 3 is equal to 0. So 50 divided by 15, then plus 1, so we got 13 divided by 3. Now we will take this on right side, so let's directly copy this here, and it is equal to minus 13 divided by 3. Let's take this as equation number 1. Now we will apply KCL at node V2. Apply KCL at node V2. Now here again the entering currents are I3 and I5. These are the entering currents. So I3 plus I5, I3 plus I5 is equal to I4. I3 plus I5 is equal to I4. Now we will write this I3 in voltage form, so it will be again same V1 minus 20 minus V2. V1 minus 20 minus V2 divided by resistance value is, again it is 20. So 20, then plus I5. This I5 in voltage form will be 15 minus V2. 15 minus V2 divided by resistance value. The value of resistance is 30 ohm. So 30, it is equal to I4. Now I4 in voltage form will be V2 minus 0 divided by 40. V2 minus 0 divided by 40. Now let's simplify this. So it will be V1 divided by 20. V1 divided by 20 minus 20 divided by 20. Then minus V2 divided by 20. V2 divided by 20. Then plus 15 divided by 30. Then minus V2 divided by 30. Then if we take this on left side, so it will be minus V2 divided by 40. It is equal to 0. Now let's take this V1 common here. So it will be V1 in bracket 1 upon 20 is again 1 divided by 20 is 0.05. So it will be 0.05. Then if we take this V2 common, so plus V2 in bracket minus 1 upon 20 minus 1 upon 20, then minus 1 upon 30 minus 1 divided by 30 minus 1 divided by 20, then minus 1 divided by 30, then minus 1 divided by 40, minus 1 divided by 40. So this will be minus 13 divided by 120, minus 13 divided by 120. Now we will solve this constant, so it will be minus 1. So let's write minus 1, 20 divided by 20 is minus 1, then plus 15 divided by 30. So 15 divided by 30, it is minus 0.5. So minus 0.5 is equal to 0, or we can directly take this on right side, so it will be plus 0.5. Now let's say this is equation number 2. Now we got two equations, equation number 1 and equation number 2. So solving equation 1 and 2, we get V1 is equal to and V2 is equal to. So let's solve this. Mod 5, then 1. So it is minus 13 divided by 60. Then it is 0.05, 0.05. Then minus 13 divided by 3. Then from equation 2, this will be 0.05. It is minus 13 divided by 120, and it is equal to 0.5. Now this will be V1 is equal to 21.19 volt, and V2 is equal to 5.16. 5.16 volt is the value of V2. But here in this question we have to find the current in 40 ohm and 10 ohm resistance. So we have to find current I4 and current I2. So first of all, let's find the value of current I2. I2 will be equal to I10 ohm. That is the current through 10 ohm. So I10 ohm, and it is equal to V1 minus 0 divided by 10. V1 minus 0 divided by 10. The value of V1 is 21.19 divided by 10. So it will be 2.119 ampere. So this is the value of I10 ohm, 2.119 ampere. Now next is I40 ohm. So I4 is equal to I40 ohm. I4 is equal to I40 ohm is equal to, this will be V2 minus 0 divided by 40. V2 minus 0 divided by 40. The value of V2 is 5.16. 5.16 divided by 40. 5.16 divided by 40. So it is equal to 0.129. 0.129 ampere is the value of current I40 ohm. That is the current through 40 ohm resistance. It is 0.129 ampere. So this is how we can find the values of current by using nodal analysis. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, Check the link in the comment section and install the app for free. Nodal analysis question. Find the value of current I. Here in this circuit, we have to find the value of current I by using nodal analysis. Solution. First of all, let's copy this circuit from here. Now let's say this is node 1 with voltage V1, and let's say this is node 2 with voltage V2, and this is the reference node with 0 voltage. Now let's apply KCL at node V1. Before that, let's assume this is current I and this is current, let's say this is current I1 and this is current I2. Now apply KCL at node V1. According to KCL, that is Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here the entering current is, at this node here we can see the entering current is this 6 ampere. So 6 ampere is equal to, leaving currents are I1, I and 3 ampere. So it will be I1, then plus I, then plus this 3 ampere. These are the leaving current from this node. Now here we can write, if we take this 3 on this side, so it will be 6 minus 3. So 6 minus 3, that means it is 3, is equal to I1, I1 plus I. Now we can write this, let's write I1 here, I1 plus I is equal to 3. Now we will convert this I1 in voltage form, so it will be V1 minus V2, V1 minus V2 divided by the value of resistance is 4 ohm plus current I. So it will be V1 minus 0 divided by 8. V1 minus 0 divided by 8 is equal to 3. Now let's simplify this further. So it will be V1 by 4 minus V2 divided by 4, then plus V1 divided by 8 is equal to 3. Now if we take this V1 common from here, so it will be V1 in bracket 1 by 4 plus 1 by 8. 1 by 4 plus 1 by 8. So it is 0.375. Then plus V2, it will be minus 1 by 4, it is 0.25 minus 0.25 is equal to 3. Let's say this is equation number 1. Now next we will apply KCL at node V2. So let's apply KCL at node V2. Now according to KCL, again, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see the entering currents are this I1 plus 3. So I1 plus 3 is equal to leaving current. Here the leaving current is only I2. So it will be I2. Now this I1 in voltage form will be V1 minus V2 divided by 4. V1 minus V2 divided by 4, then plus 3 is equal to V1 minus V2 divided by 4, then plus 3 is equal to I2. Now this I2 will be V2 minus 0 divided by 6. V2 minus 0 divided by 6. Now let's simplify this. So it will be V1 divided by 4 minus V2 divided by 4, then plus 3 If we take this on left side, so it will be minus V2 divided by 6 is equal to 0. Now here we can take this V1 common. So V1 in bracket, this will be 0.25. Then if we take this V2 common, so it will be minus 1 by 4. Minus 1 by 4. Then minus 1 by 6. Minus 1 by 6. Minus 1 by 4 minus 1 by 6. So it is minus 5 by 12. Minus 5 by 12. And if we take this 3 on right side, so it will be minus 3. Let's say this is equation number 2. Now we got two equations. Now if we solve these equations, solving equation 1 and 2, we get V1 is equal to and V2 is equal to. So let's put this in calculator. Mod 5 then 1. So it will be 0.375. 0.375. Then here this will be minus 0.25. Then constant is 3. Then from equation 2, it will be 0.25. 0.25. Then minus 5 divided by 12. Minus 3. So this is the value of V1. It is 21.33. 21.33 volt is the value of V1. And then the value of V2. It is 20. Now we got the value of V1 and V2. What we have to find in this question? Its unit will be volt again. What we have to find in this question? We have to find the value of current I. So we have to find this current I, and I is equal to, here we can write I is equal to V1 minus 0 divided by 8. V1 minus 0 divided by 8. The value of V1 is 21.33 divided by 8. So it will be 21.33 divided by 8. So it is 2.66. 2.66 ampere is the value of current I. 2.66 ampere. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, if you want the electrical engineering dictionary app, check the link in the comment section. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question: find the value of current I by using nodal analysis. Here we can see we have to find this current I. Solution: first of all, let's say this is a node 1 with voltage V1, and let's say this is a reference node. Let's assume this is current I1. Here this is the positive terminal of battery, so the current will flow from here to ground, and here the current will flow from here to ground. Let's say this is current I2. Now let's apply KCL, that is Kirchhoff's current law, at node V1. So according to KCL, summation of all the currents entering a node is equal to summation of all the currents leaving a node. Now here we can see at this node the entering current is, or entering currents are, this I1 is the entering current and this I2 is also the entering current. So it will be I1 plus I2 is equal to leaving current is I. Now here we can write this I1, I2 and I in voltage form. So this I1 will be 5 minus V1, that is higher voltage, minus lower voltage. So it will be 5 minus V1 divided by resistance value will be 2 plus 1. So 2 plus 1, it is 3, then plus I2. Now this I2 will be 4 minus V1, 4 minus V1 divided by resistance value 2 ohm, it is equal to current I. Now this I will be V1 minus 0 divided by 3. So V1 minus 0 divided by 3. Now we can easily find the value of current I from this. So let's simplify this. So it will be 5 by 3. So let's write it here. 5 divided by 3. Then minus V1 divided by 3. Then plus 4 divided by 2. Then minus V1 divided by 2. Then if we take this on left side, so it will be minus V1 divided by 3 is equal to 0. Now here let's take this V1 common. So it will be V1 in bracket minus 1 by 3. So let's write minus 1 by 3. Then minus 1 by 2. Minus 1 by 2. Then minus 1 by 3. Minus 1 by 3. So it is minus 7 by 6. Minus 7 divided by 6. Now if we simplify this 5 by 3. So it will be 5 divided by 3. Then plus, it is 4 by 2. It is 2. So it will be 11 by 3. So plus 11 by 3 is equal to 0. If we take this on right side, so it will be minus, and this minus minus will get cancelled. So it will be V1 7 by 6. 7 divided by 6 is equal to 11 by 3. So therefore V1 is equal to this 11 by 3 multiplied by 6 by 7. So it will be 11 by 3 multiplied by 6 by 7. So it is 3.142. 3.142. Since it is a voltage, so its unit will be volts. But here we have to find the value of current I. So current I is equal to V1 minus 0 divided by 3. I is equal to V1 minus 0 divided by 3. The value of V1 is 3.142 divided by 3. So if we solve this, we get 1.047. 1.047. Since it is current, so its unit will be ampere. So I is equal to 1.047 ampere. So this is how we can find the value of current I by using nodal analysis. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question. Find voltages at nodes A and B in figure. Here in this circuit, we have to find its node voltages, that is node A voltage and node B voltage by using nodal analysis method. Solution. First of all, let's assume this is a reference node with 0 voltage. Let's say this node voltage is VA and this node voltage is VB. Let's assume this is current I1, this is current I2, this is current I3, this is current I4 and this is current I5. All the currents towards this reference node. Now first of all, let's apply KCL at node VA. So apply KCL at node A. Its name is node A and its voltage is VA. So according to KCL, KCL stands for Kirchhoff's current law. Summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here the entering currents are I1. At this node, here we can see only this I1 is the entering current, and this I2 and I3, these are the leaving currents. So here we can write I1 is equal to I2 plus I3. Now we can write this I1 in voltage form. So it will be higher voltage, that is 15 volt, minus lower voltage. So 15 minus VA divided by 5. 15 minus VA divided by 5, it is equal to I2. Now I2 will be VA minus 0 divided by 8. VA minus 0 divided by 8, then plus I3. Now this I3 will be VA minus VB divided by 6. VA minus VB divided by 6. Now if we separate this, so it will be 15 by 5. 15 divided by 5 minus VA divided by 5 is equal to VA by 8, then plus VA by 6, then minus VB by 6. 15 by 5, VA by 5, then is equal to VA by 8 plus VA by 6 minus VB by 6. Now let's simplify this further. So if we take all this on left side, so it will be 15 by 5. So it will be 3 minus VA by 5, then minus VA by 8, then this will be minus VA by 6, then this will be plus VB by 6. It is equal to 0. If we take this VA common from here, so it will be VA in bracket minus 1 by 5 minus 1 by 5, then minus 1 by 8, then minus 1 by 6. So it is minus 59 by 120. Minus 59 divided by 120 and plus VB in bracket, this will be 1 by 6. 1 by 6. And it is equal to, if we take this 3 on right side, so it will be minus 3. Let's say this is equation number 1. Now let's apply KCL at node B. So if we apply KCL at node B, then again according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see at this node B, the entering currents are I5 and I3. These are the entering currents. So I5 plus I3, I5 plus I3 is equal to leaving current is I4. I4. The value of I5 is, here we can see I5 is equal to 5 ampere, because here this is a current source. So therefore I5 is equal to 5 ampere. So 5, then plus, now I3. Now I3 will be VA minus VB divided by 6. VA minus VB divided by 6 is equal to I4. Now I4 will be VB minus 0 divided by 9. VB minus 0 divided by 9. VB minus 0 divided by 9. Then further simplify this, so we get 5 plus VA by 6 minus VB by 6 then is equal to VB divided by 9. Now if we further simplify this, so it will be VA divided by 6 minus VB divided by 6. Then if we take this on left side, so it will be minus VB divided by 9. Then VA by 6 minus VB by 6 minus VB by 9 is equal to minus 5. So if we take this VA common, so it will be 1 by 6 here and plus VB. So if we take this VB common, so it will be minus 1 by 6 minus 1 divided by 6, then minus 1 by 9, minus 1 divided by 9, so it is minus 5 by 18, minus 5 divided by 18, it is equal to minus 5. Let's say this is equation number 2. Now we got two equations, equation number 1 and equation number 2. So solving these two equations, solving equation 1 and 2, we get mod 5 then 1 minus 59 divided by 120, 1 by 6 minus 3. Then from equation 2, this will be 1 by 6 again minus 5 by 18, then minus 5. So therefore VA is equal to 15.31 volt, 15.31 volt, and VB is equal to 27.19 volt. So this is the value of VA and VB. What we have to find in this question? We have to find voltages at nodes A and B in figure by using nodal analysis. So this is how we can find the nodal voltages by using nodal analysis. Check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Nodal analysis. Question: find current through 8 ohm resistance. Here in this circuit, we have to find the current through this 8 ohm resistance by using nodal analysis method. Solution: first of all, let's assume this is a reference node or ground node with 0 voltage. Let's assume this is a node A with voltage VA. Let's assume this is current I1, this is current I2, and this is current I3. All the currents direction towards this reference node from positive terminal of battery to this reference node. Now let's apply KCL at node VA. So here we can write apply KCL at node VA. KCL stands for Kirchhoff's current law. According to KCL, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see the entering currents are at this node. This I1 is the entering current and this I3 is the entering current. So here we can write I1 plus I3. And here we can see the leaving current is I2. Leaving current is I2. Now the I1 in voltage form is higher voltage minus lower voltage divided by resistance. That is 20 minus VA divided by 6. 20 minus VA divided by 6, then plus I3. Now I3 will be 12 minus VA, 12 minus VA divided by 10 is equal to I2. VA minus 0, so here we can write only VA minus 0 divided by 8. Now if we simplify this, so it will be 20 by 6 minus VA by 6 plus 12 by 10 minus VA by 10 is equal to VA divided by 8. Now further, if we simplify this, so it will be, if we take this on left side, so let's write it here only. So it will be 20 divided by 6 minus VA divided by 6 plus 12 by 10 minus VA divided by 10 minus VA divided by 8 is equal to 0. If we take this VA common from here, so VA in bracket, this will be minus 1 by 6 minus 1 upon 6, then minus 1 upon 10 minus 1 upon 10, then minus 1 upon 8 minus 1 upon 8 minus 1 upon 6 minus 1 upon 10 minus 1 upon 8. It is equal to minus 47 divided by 120. Now if we solve this, 20 by 6, so it will be 20 divided by 6, then plus 12 divided by 10, then it is equal to 68 by 15. So here we can write plus 68 divided by 15 is equal to 0. Now if we take this on right side, so it will be VA in bracket 47 divided by 120, it is equal to 68 divided by 15. So therefore VA is equal to 68 divided by 15 multiplied by 120 divided by 47. So therefore VA is equal to 68 divided by 15 multiplied by 120 divided by 47. So it is equal to 11.57. 11.57. Since it is a voltage, so its unit will be volts. Now we got the value of VA. Next we have to find the value of, in this question we have to find the value of current through 8 ohm resistance. That means we have to find the value of this I2. So here we can write I2 is equal to I8 ohm and it is equal to VA minus 0 divided by 8. VA minus 0 divided by 8. The value of VA is 11.57 minus 0 divided by 8. So it will be answer divided by 8. It is 1.446. 1.446, and since it is current, so its unit will be ampere. So therefore the current through 8 ohm resistance will be 1.446 ampere. So this is how we can find the value of current by using nodal analysis. Check the link in the comment section and install the app for free. Thanks for watching.